Alright, so part 3. This question's a bit of a monster, so I've got a piece of paper because I'm not going to have space otherwise. It says, the diagram shows triangle ABC. The area of the triangle ABC is k root 3 centimeters squared. Find the exact value of k. Then we've got our diagram with all of these x's in. We're going to have to work out what x is first of all, and we can do that by using the cosine rule. So what we're going to do is, well, this is our angle that we know, therefore this is going to be A. So that means that if we write this out, we get 2x minus 1 squared equals our other two sides, x minus 1 squared plus x plus 1 squared minus 2 times x minus 1 x plus 1 and at this point times cos 120. So cos 120 is actually quite a nice number. It's minus half, so I'll just pop that in on the end, times minus a half. Okay, then it is a question of multiplying out our brackets. We can use, because these are all squared, remember they're two identical brackets, so what we can do is we can go for this one, 2x minus 1, 2x minus 1, 2x times 2x is 4x squared, 2x times minus, that's minus 2x, that's minus 2x, and minus 1 times minus 1 is plus 1. If we multiply out this next one, we've got x minus 1, x minus 1, so that's x squared minus x and plus 1. If we multiply out this one, we've got x plus 1, x plus 1, so x squared, x and 1. And then these two brackets be multiplied together as well, so we can multiply out these as well. So we'd have x minus 1, x plus 1, x squared minus x minus 1. Okay, so now if we collect like terms for this one, we would have 4x squared minus 4x plus 1. For this one, we'd have x squared minus 2x plus 1. For this one, we'd have x squared plus 2x plus 1. And for this one, we would just have x squared minus 1, because these two cancel each other out. Now the other thing is, we've got, if we thought of this as, rather than take away two lots of all of this, if we did minus 2 times minus half, guess what's going to happen? It becomes 1. So these two things here cancel each other out, and we can just ignore them, as it were. We are basically going to add on to the multiplication, multiplied out this bracket, multiplied out this bracket, and these two, we're just going to add it all on because they cancel each other out. Two negatives make a positive, and because they're reciprocals, they cancel each other out to 1. So now we can rewrite out our equation. We've got 4x squared minus 4x plus 1 equals, because that's one side of our bracket, we're going to add all of these things together. So x squared plus x squared plus x squared is 3x squared, minus 2x plus 2x, they cancel each other out, plus 1 minus 1 is plus 1. Suddenly become an awful lot more manageable. Everything seems to have disappeared quite nicely, cancelled each other out. Now what we're going to do is rearrange it so that one side is 0. This side's got the most x squared, so I'm going to remove everything from this side and pop it so that this side becomes 0. So we're going to take away 3x squared from both sides, which leaves us with x squared. No x's to deal with here. Oh, and 1 and 1, they take away each other to make 0. Okay, so now what we've got to do is solve this. It will factorise because x times x is x squared and x times minus 4 is minus 4x. Now there are two solutions because it's a quadratic. Now normally we'd see two brackets, but this one hasn't quite worked out because there was no constant. It hasn't worked out in that way. So we've got two ways to make this 0. Either x can be 0, or x can be, well, to make this bracket 0. Now, if x was 0, in this real world situation, if we go back, that would make this side 0 minus 1 is minus 1. We can't have a triangle with lengths minus 1. So that solution we can't use. What we're going to do now is to work out the length. We're going to use the x equals 4. So if I sketch out my triangle again, or something that looks roughly like it, we had the sides. This was x plus 1, x minus 1, and 2x minus 1. Now we know that, well, x can't be 0, otherwise this length would be negative. So this means x must be 4. So that means that this side is 3. 4 take away 1. This side is 5. 4 plus 1. And this side is 2 times 4, 8. Take away 1, 7. We also know that this angle here is 120 degrees. Now we are told, back up in the question, that the area of triangle ABC is k root 3. So we're now going to go to our area of a triangle formula, which is area equals half of AB sine C. So area we know is k root 3, they told us that in the question, and that's going to equal half, this is A and B, sine 120. Now sine 120 is also a reasonably nice value as well. It is root 3 over 2. So we can change this for we're times by root 3 over 2. We also know that x minus 1 is now 3, and x plus 1 is 5. So let's multiply all of this out. We've got half times 3 times 5. Well, 3 times 5 is 15. Times by half is going to be 15 over 2 times root 3 over 2. So now if we multiply, sorry, excuse me, lost myself a moment there. So now if we do this, if we multiply two fractions, we end up with 15 root 3 over 4. And we want to know what, well, we've got our root 3 bits, so we could rewrite this as 15 quarters times root 3, which means that k equals 15 over 4, because that is what we are multiplying root 3 by to get our answer. Monstrously beautiful question. And then we go on to question 8. Much nicer. Not drawn accurately. AC is 9.2, BC is 14.6, and angle ACB is 64. Calculate the area of the triangle. We need a sassy triangle. We've got a sassy triangle, side, angle, side. So we can go straight in there with half times A, let's call that the 9.2 side, times B, let's call that the 14.6 side, times sine C, well that's the angle between them, and actually that will just give us the area of our triangle. 0.5 times 9.2 times 14.6 times sine 64. We want our answer to correct. Oh, well, let's just write down everything just in case. 60.363000815. And we want our answer correct to three significant figures, so that's going to be 60 point, rounding up 4 meter squared. Calculate the length of AB. Well, it's a sassy triangle and we want the side opposite the angle, so we can use the cosine rule. So we know that a squared equals b squared, 9.2, times c squared, 14.6, minus 2 times b, 9.2, times c, 14.6, times cos, and our angle is 64. If we whack that in, we won't quite get our answer, but we'll be close. So 9.2 squared times 14.6 squared minus 2 times 9.2 times 14.6 times cos 64. Have I typed that incorrectly? That seems a very large number. So we've got 9.2 squared. Sorry, that shouldn't be times, that should be a plus. There we go. I'm losing my mind. Oh, that feels more like it. Okay, so that equals 180.035975. So A is going to be the square root of our answer, which is 13.4177481, and correct three significant figures. That's going to be 13.4 because that's one down. Oh, sorry, not centimeters, meters. And I think that takes us, yep, end of the booklet.